Right, hello and welcome. Today's problem says find z if x squared plus y plus z equals 1988, x plus y squared plus z equals 2020, and the other restriction is that x, y and z are positive integers. This question was sent to me by none other than the absolute champion, Mr. D. Franklin. So thank you very much for the question. Right, as always, pause and have a go, and I'll get started with my solution. So we'll start off by calling this equation 1 and calling this equation 2. The first thing I wanted to do was find the difference here, because I know that if I subtract, then the z's are going to cancel. The lesser the variables, the better. I'm going to subtract upwards, take away because the signs are the same, so I need to subtract. I'm going to get x minus x squared. I'm going to get y squared take away y, so I'm going to add that on. Y squared take away y. Z take away z, that dies. And on the right hand side, we're going to get 2020 take away 1988, which is of course 32. Right, so we've simplified it into something that looks like this. Right, the next thing I'm going to do is I'm going to write it in a slightly different way. I'm going to write it like this. And the reason I'm doing that is because now I can sort of see a difference of two squares there. And also if I do something slightly clever here, I can factorize. So let's do that. If I write this bit here as this thing here, you'll see why that's going to be helpful in just a second. And you can of course see why that's true, because that's going to be minus y, that's going to be plus x, so of course these two lines are exactly the same. And now I'm going to use a difference of squares here to get y plus x and y minus x. And of course this stays the same, y minus x equals 32. And now at this point I'm going to factorize, and of course you can see the common factor of y minus x, so I'll pull that out the front. I get y minus x, and here I get y plus x here, and of course there's 1 y minus x here that I've taken out, so I'm just going to take away the 1, and that equals to again 32. Right, at this point now I can see that I've got a product of two things to make 32. I also know from the beginning that x, y and z are all going to be positive integers, so I'm going to just make a quick list here on the side to see what these factors could be, these factor pairs, because I know they must multiply to make 32 and they can only be integers. So because 32 is a power of 2, I know it's only going to involve me multiplying powers of 2 together. So I can have 2 to the power of 0 times by 2 to the power of 5. I can have 2 to the power of 1 times by 2 to the power of 4. I can have 2 to the power of 2 times by 2 to the power of 3. And these are the only options that I really have. Of course, I can swap them around and I could continue the list, 2 to the power of 3 times 2 to the power of 2, but there's no need because I could just swap these factors around. And of course, 2 to the power of 5 is 32. That's why the total of these two exponents is always going to be 5. Another thing that you need to observe at this point is that the sum of these two factors, so if I add up these two factors here that I'm multiplying to make 32, well, the sum, well, that's y minus x add y plus x minus 1. That's 2y. Y add y is 2y. Minus x add x is nothing. And then you've still just got minus 1 there. So of course, because y is an integer, this thing must be odd. The sum of these two factors must be odd. And I'll do something similar for the difference. So the difference here between these two factors, of course, that's the bigger factor. So I'll do that, take away that. If I do y, take away y, that's 0 y's. X, take away a negative x, that's 2x. And there's a minus 1 there. And of course this is again going to be odd because I know x has to be an integer. 2 times by any integer makes an even integer. If I take away 1, I get an odd integer. Therefore, both the sum and the difference of these two factors must be odd. What I'll do here is I'll just write these in a more easy to understand way. That's 1 times 32. That's a possible choice. You have 2 times 16, that's another possible choice we have for the factors. And of course we have 4 times 8. Of course I could switch these around, but I already know they're in the right order because this is the smaller one and this is the bigger factor. It's quite clear because y and x are both positive integers. And of course, if I know that the sum and the difference of these two factors must be odd, then the only one that's going to work is this one. Because 1 add 32 is 33. 32 take away 1 is 31. They're both odd. If I do the same thing with 2 and 16 or 4 and 8, I'm going to get evens and I don't want them. So 1 and 32 must be the value of each of these factors. So we had that y minus x and y plus x minus 1 equals 32. And of course we also said that this must be 1 and this must be 32. And at this point now all we have to do is solve the simultaneous equations. Y plus x minus 1 equals 32 and y minus x equals 1. And it's pretty obvious to see that y is going to be 17 and x is going to be 16, but I will go ahead and quickly do the method. If you just add up these two, you notice that you're going to get 2y. Y add y is 2y. X minus x is nothing. Minus 1 is going to remain on the left hand side. 32 add 1 equals 33. And of course, add the 1, divide by 2, you get that y must be 17. And if y is 17, then 17 take away 16 must give me a 1. Hence, this would be the values of x and y. So if you think right back to the start then, it said x squared plus y plus z equals 1988. I know what x is, I know what y is, and the question was to find out what z is. So all I'm going to do now is substitute these numbers into here, and hopefully we'll end up with some value for z. You could have used the second equation of x plus y squared plus z equals 2020, but that's just up to however you want to go about it. So I'll substitute it in. I get 256 plus 17 plus z equals 1988, and this is the hardest bit now because now you have to do subtractions. So z equals 1988, take away 256, take away 17, and this comes out to be 1715. And that's it. I hope you enjoyed the video. Thank you very much. Goodbye.